Hello class, in this video we cover some basics about set. Set is a collection whose contents are clearly determined. The members in a set is called elements. Very important, we need to know, in order for a collection to be a set, the contents have to be clearly determined. Let's look at those two examples. A. The collection of full-time and part-time students currently enrolled at the TCC. This is a clearly determined collection, so it is a well-defined set. All the elements in the set are full-time and part-time students currently enrolled at the college. Part B. The collection of elderly full-time students currently enrolled at the TCC. So this is not clearly determined. Elderly, how old is old? How old is defined as elderly? 60 above or 70 above? So not clear. So this is not a well-defined set. We have three methods to represent sets. They are order description, roster format, and set builder notation. Let's look at the examples and talk about the three methods of representing sets. Let's use the order description to describe each of the following sets. A is a set containing two elements, April and August. We can say set A is the set of month. Set of month is the set of all months with the initial letter A. Okay, yeah, we have 12 months. Only April and August with initial A. And B, set B is the set of all natural numbers bigger than 2 and less than 16, right? Yeah, all the natural numbers bigger than 2, so start from 3, and less than 16, so ends at 15. All natural numbers. You don't have a hyphen in it too. All natural numbers bigger than that are bigger than 2 and less than 16. Use the roster method. Use the roster method, we need to use a set of braces and put all the elements in the braces. A set of 7 natural numbers, sorry, even natural numbers less than 10. Even natural numbers start from 2, 2, 4, 6, 8, less than 10. 10 is not an element, only 4 elements. And part B. B is a set contains the solution of the equation. So set B actually is the solution set of the equation behind the bar. Some books use a slash, same thing. So the equation is x plus 3 equals 9. Yeah, what's the solution of the equation? You can quickly solve it. Subtract 3 from both sides. We have x equals 6, right? It only has one solution. So the set B is a set contains one element only. The element is 6. So we put a 6 in it. That is the roster method to represent a set. Empty set is a very important concept. There are only two notations could represent the empty set. Either this one, a circle with slash across the circle, or you use a set of braces with nothing in it. Very important, knowing that those two. Common mistake is to mistaking those two sets as the empty set. They are not, okay? Knowing that those two sets are not empty sets. Let me explain. This set is not empty because it has one element. The one element is an empty set. Yeah, element could be anything. In this case, the only one element in a set is the empty set. Similar with this one. This is not empty. It has one element. The only one element is number 0. Let's determine if the following set empty or not. A is not empty. Yeah, I can draw a real number line. Feel free to pause the video. When I teach face-to-face class, I'm a lot slower. When I'm making the video myself, I try to go faster, but you can pause the video anytime, right? This is 0, this is 3, this is 5. So any real numbers less than 3 or greater than 5, all the real numbers less than 3 or greater than 5. So all the numbers covered by the red region, they are elements of the set. There are infinitely many elements in the set. It's not empty, okay? It's not empty. And part B, the difference between A and B is this logic connective. In set A, we have or, right? But in set B, we have and. That makes a huge difference. Yeah, which number is less than 3 and at the same time bigger than 5? Do we have a number less than 3 and bigger than 5? We don't, right? It does not exist. Yeah, it does not exist. So this set is empty. Because there's no such element exists. The set is empty. There's no element satisfy the condition behind the bar. No element, no number less than 3 and bigger than 5. This is not empty. We talked about that just a moment ago. And D, nothing is just a word. I don't see that as the empty set. Elements. You know, we use capital letters to represent sets and use lowercase letters to represent elements. And how do we describe the relationship between elements and sets? We have those two notations, one or the other. Yeah, let's say A is an element, capital letter A is a set. A is either belongs to, yeah, is actually called A is either an element of set A or A is not an element of set A, one or the other. Sometimes I say belong to, but the formal way to describe that is an element. This represents A is an element of A, set A. And this notation represents letter A, lowercase a, is not an element of set A. Okay, let's use the notation. And now we understand the notation. Let's determine, is the following statement true or false? Statement A, 10 is an element of this set. And this set includes all the natural numbers from 1 to 16. You don't see 10 in it, but actually 10 is one of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, they are represented by dots, dot here. So yes, this is true because 10 is an element of the set. Part B, statement B is true as well. Statement B says 17 is not an element of the set. That's correct because 17 is not one of the elements, literally not part of the set, right? It does not belong to the set. The statement is true. When you see the fancy letter capital letter N in mathematics represents the natural number set. Natural number set. We have infinitely many natural numbers from 1 to infinity, right? 1, 2, 3, 4, 5, and then infinity. The smallest natural number is 1. Part C, statement C says 2 is an element of this set. Well, let's figure out what is this set. This set is in the set builder notation. Yeah, X and then a bar or slash, and the description of the element is behind the bar. X is a natural number and X is odd. Odd natural numbers. Odd natural numbers we include 1, 3, 5, 7, 9, 11, and so on and so on, right? 2 is not one of them. So this is a false. Okay, this is a false. 2 is not. Yeah, to fix it, we should change the connection as not an element of. Part D. Part D is true. Why is it true? Because the set contains all the natural numbers strictly less than 20. So 20 is not an element, which is true. Part E is false. It's kind of confusing, but this is a set, okay? Yeah, this is a set. This is a set with one element, 7. And this is also a set. We do not use the notation, this or that, to connect the two sets. If I change the statement as this, you know, then it's a true statement. Yeah, the set with one element 7 is an element of the set on the right. That is a true statement, but this is not a true statement. Okay, because 7 is a number, and this is a set with number 7 in the element. We do not use the notation is an element of or is not an element to. So basically this is not an element, right? Yeah, this set is not an element of the set on the right. And let me know if you see the difference between the two statements. This is a false, but this is a true. Cardinal number, also called a cardinality. Cardinality of a set or cardinal number of a set refers to the number of elements in a set. The number of elements in a set. If we have a set, we count how many elements in it, and the number of the elements is called the cardinality of the set. Pretty straightforward, simple concept. So set A has 1, 2, 3, 4, 5 elements, so the cardinal number is 5. Set B has 1 element, so cardinal number is 1. Set C has 1, 2, 3. We have 12 here, 13, 14, 15, 16. So 1, 2, 3, 4, 5, 6, 7, 8. 8 elements, so cardinal number is 8. Set D is the empty set. Empty set all has cardinal number 0 because it has no element, right? Equal and equivalent. You will see a lot questions in MATLAB Math about equal and equivalent. To make two sets equal to each other is very strict. A and B are equal to each other as sets, means they are exactly the same. In order for two sets are equal, they have to be exactly the same, have the same number of elements, and all the elements are exactly the same. Very strict. On the other hand, equivalent is kind of looser and not that strict. When we say two sets are equivalent, we mean A and B have the same cardinal number. This notation means if and only if both directions apply. If two sets have the same cardinal numbers, then they are equivalent. Vice versa, if the two sets are equivalent, then they must have the same cardinal numbers. Let's determine A and B in this example. Are they equivalent? A has cardinal number 5. B has cardinal number 5. So yes, they are equivalent. However, they are not equal. They are not equal because they do not have exactly the same elements. In fact, their elements are all different. Last set of concepts, finite and infinite. Finite set refers to a set with a limited number of elements. An infinite set represents a set containing unlimited number of elements. Let's see A and B. So means is a cardinal number wise, right? Yeah. Set A, if I write the set is given in the set builder notation. If I use the roster method to write a set, let's see what are the elements. Set A has all the elements, are natural numbers. Yeah. Set A contains elements that are natural numbers and less than or equal to 2 million. So set A is a set containing the first 2 million natural numbers. So it has 1, 2, 3, 4, all the way to 2 million. 2 million is a huge number. However, the set is finite. Even 2 million is a very large number. The set is finite because 2 million is still a limited number of elements. Set B instead is infinite because set B contains all the natural numbers bigger than 100. So start from 101, 102, 103, and so on and so on and so on and so on, all the way to infinity, right? Yeah, so infinitely many elements. Okay, guys, that's everything for section 2.1. You can work on your assignment in MATLAB Math. If you have any questions, feel free to email me. I'll see you in the next section.